All right, imagine you're walking through a lush forest. You take a deep breath, fresh, earthy air, loaded with oxygen and something else. Carbon dioxide being sucked out of the atmosphere by these towering trees. Now, have you ever wondered how scientists actually measure how quickly forests store away carbon from the air? This is where a bit of math's magic comes in. So, let's dive into differentiation, not as scary as it sounds, I promise. In forest resource technology, one key question is, how fast is a forest capturing carbon at any given moment? That's the rate of carbon sequestration. If CT is the total amount of carbon stored in a forest at time t, then the rate at which this carbon increases is given by the derivative dc/dt. That's just a fancy way of saying the change in carbon over time. Let's put this into a real-world context. Suppose after monitoring a patch of forest, researchers find that the carbon stored follows the function CT equals 1000 plus 60t0, 5t2, where t is measured in years. That means as years pass, the forest stores more carbon, but the rate might not always be the same. So how do we find out how fast the forest is storing carbon right now? We differentiate. Taking the derivative dc/dt gives us 60t. That's our rate of sequestration, in tons per year. Let's say it's been 20 years since the forest was measured. Plug t equals 20 into the formula dc/dt equals 6020. That's 40 tons per year. So right now, this forest is locking away 40 tons of carbon from the atmosphere every single year. But here's where it gets interesting. As t increases, dc/dt decreases. Eventually, the forest gets older and starts storing less and less carbon annually. That's why young, fast-growing forests are carbon sponges, while ancient forests are more like carbon vaults. They keep a lot in, but don't add as much each year. So differentiation isn't just a dry textbook exercise, it's how we track the heartbeat of our forests. It helps scientists figure out which parts of the forest are most effective at fighting climate change, and when. Next time you're out in the woods, remember there's a whole world of maths happening all around you. And with a bit of differentiation, you can read the secret story of how our forests help save the planet. Crack open those textbooks, give the numbers a whirl, and you'll see. Maths is everywhere, even in the whisper of the trees.